So quiz 2, who's my favorite student? Good old Anne. Most of these involved friction or air resistance, which honestly, Colby, you can kind of think of it as air friction. I kind of do sometimes. So, number 1 said this: an object is pulled at a constant speed. Pretty much anytime I see that phrase, I underline it. What that means in this case is that forces are balanced. A is 0. The net force is 0. That's different ways to say the same thing. It wants the coefficient of friction. I did a quick free body diagram, although since they gave me the picture, I just labeled the picture. I said, okay, it's going to be mg down. I don't see any extra vertical forces, so I think the normal force is the same side as mg. I said this here is F applied. How long should I have drawn that friction arrow? Bigger, smaller, or the same size as the 12? Why same size? Yeah, and so because of that, I can take a big shortcut. I can just say, you know what? Friction equals 12. It has to be. Okay. If you're doing winner minus loser, you would go like this. 12 F applied minus friction equals MA. And then you would say, Evan, A is 0. So you would go 12 minus friction equals 0. Then you would plus the friction over. You would get 12 equals friction, and lo and behold, you end up right here as well. So you can still do it the long way with winner minus loser. What I am telling you though is if you do know that A is 0, that means you can make a lot of clever assumptions and save yourself some time. It wants me to find the coefficient of friction, which is hidden inside of the equation for friction. So my next step would be to write friction equals mu times the normal force. That equals 12. Coefficient of friction is the mu. I want to get the mu by itself. I would divide by the normal force. I don't know the normal force. Oh, but look. The normal force, it looks like, is mg in this case. So it's going to be 12 divided by mg. It's going to be 12 divided by 5 times 9.8. That's going to be roughly 12 divided by 48. It's going to be really close to 0.25. Is it A? Or am I wrong? Is it A? Yeah, okay, that was a guess, but an educated guess. I kind of crossed out in my mind C and D. Those would be really sticky. If it was dragster tires, maybe, or something unusual, but I didn't see that here. So mentally, I kind of went, I don't think it's those. A freely falling object falling downwards and accelerating downwards. That's important. Okay, this is a job for a free body diagram. I have gravity down. I have air resistance up. Now, I know air resistance is shorter because it told me we're accelerating downwards. If it had said slowing down, I would know air resistance was bigger. It would be the winner. But in this case, it says we're accelerating downwards, not accelerating upwards. So my equation is going to be winner minus loser equals MA. Okay. Declan, what did this question want me to find? How? Trayson's theorem. Or I would have no problem giving you the same question on the test, Bella, but giving you the acceleration and asking you to find the air resistance. To get F air by itself, there's a negative. You would do a swappy dance in this case. But yeah, this just wants us to find the acceleration. We'll use Trayson's theorem. A is going to be M, 0.62, G, 9.8, minus, they told me F air, 1.4. How do I know that's a force? Newtons. Divided by 0.62, the mass. I have no idea what this answer is. Bracket 0.62 times 9.8 minus 1.4 divided by 0.62. Is it 7.54? Anyone else? People nodding? 7.54 meters per second squared. If you got that, I would give you 2 out of 2. Otherwise, I would give you a half mark if I saw this equation. I would give you a half mark for dividing by the mass. I would give you a half mark for the numbers and a half mark for the answer. Number 3, the what force? The net force. So I can go straight to F equals ma. I guess I'm going to need to find A. from rest. So Marlon, we learned from rest means VI is 0. This is VF. And D is 85. I think I'm going to use VF squared equals VI squared plus 2AD. And if I get the A by itself, I think A is going to be VF squared minus VI squared all over 2D. It's going to be 15 squared minus 0 squared all over 2 times 85. That I don't know what it is. It's going to be 15 squared. The minus 0 squared isn't going to change anything. I get 1.3235. I'm going to write 1.32. I'm going to walk it over here, but I'm going to use my answer button. F equals 1200 times, I'm going to write 1.32, but I'm going to use my answer button on my calculator. Final answer. Let's see what we get, Mr. Dueck. 1200 times answer button. Did y'all get 1588? I'm going to go to 3 sig figs. I'll write it as 1590. That's newtons. If you got that 2 out of 2, otherwise I would give you a half mark if I saw that you had written F equals ma, a half mark for that. I would give you a half mark if I saw this equation, and a half mark for the acceleration. That means you probably used a rounded off, the 1.32. I'll give you full credit, but be lazy. Use your answer button. It's more accurate, it's less typing, and it's less chance of a typo. It's the only triple win out there, right? But yeah, you're fine with that. Block initially at rest. I'd mentally underline at rest. Okay. They want the final speed, so I said, all right, VF equals question mark, VI equals 0, D is 16. Do you know what I need to find VF? I said to myself, I need to find the acceleration. That I'm going to do using Newton's laws. This is a job for a free body diagram, although since they gave me a picture trace and I'm just going to label the picture, I said, okay, I have gravity down. I don't see any extra vertical forces, so the normal force is the same size as mg. This 56 coming from off the page, we've decided to call the mystery force an applied force, just a generic term. And there's a coefficient of friction, so I know there is friction there. I know F applied must be winning because we started at rest. The only way it would have started accelerating would have been if this was bigger. So when I do my equation here, I'm just going to draw a little line, little line like that. I'm going to go, okay, winner, F applied, minus loser, friction, equals what? MA. I want A, so I'm going to use Trayson's theorem to get the A by itself. A is going to be F applied minus mu times the normal force over M. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. Gabby, which force is going to be the same size as the normal force? And so I'm fine if you're getting good at this. I'm fine if out of laziness you just do that. That's telling me I know it's mu times the normal force. It's not mu mg, it's mu times the normal force. But then I cleverly reasoned that the normal force in this simpler one with no vertical arrows was equal to mg. So I'm fine if you do that. Let's get A, Mr. Dueck. What was F applied? It was 50 something, 56? Minus what's mu? I don't know what's mu with you. 0.24 times 12 times 9.8 all over 12. This might work out nice. 56 minus 0.24 times 12 times 9.8 divided by 12. Oh, almost repeats. I get 2.31, but I'm going to, and again, if you use the 2.31, Evan, I'm fine with that. You know I'm going to use my answer button. I'll write down 2.31 meters per second squared. Is that the right acceleration, folks, for people who've done this? People nodding? A lot of you haven't done the quiz. You're setting yourself up for some ugliness on the test. Now, to find VF, I'm going to use VF squared equals VI squared plus 2 VAD, although VI is 0. That's VF squared. Ooh, how to get rid of a squared? Two, I'm actually going to put my answer button right there, times 16. So I'm going to go 2 times 16 times answer button, or 2 times answer button times 16, square root of that. If you carry your answer button through, you'll get 8.61. So I would accept 8.6 something meters per second. If you got that, I would give you 3 out of 3. Otherwise, I would give you a half mark if I saw that. I would give you a half mark for the numbers, half mark for the answer. I would give you a half mark if I saw that, half mark for that, half mark for that. Oh, Mr. Dueck, what a great drawing. Well, thank you. I'm proud of that. It wants me to find the acceleration. This is a job for a free body diagram. What are the forces acting? Since they gave me the picture, I'll just label the picture. I have gravity down. I think in this case, normal force up. And then we said you can call this F snow, whatever. There is an applied force pushing them forward with 110. I said, even though you're pushing backwards, it's a forces come in pairs. The snow, the poles on the snow, you're getting pushed forward. There is a force forwards. And then there is some friction in snow slowing us down. Who's winning? I'll call it F applied. If you called it F pole, or if you called it F snow, F push, I'm fine with that. I'm not that fussy. Then we have minus friction equals ma. Here they want me to find the acceleration. Again, Nicole, I would have no problem giving you the acceleration and asking you to find F applied, or asking you to find the coefficient of friction, which is hidden inside there. But in this case, we can use Trayson's theorem. A is going to be 110 minus mu times the normal force all over m. I don't know the normal force, but in this case it's mg. So I can go 110 minus 0.11 times, what was m, Mr. Dueck? 47 times 9.8 all over 47. 110 minus 0.11 times 47 times 9.8 divided by 47. Did y'all get 1.26? Yep, 1.3. If you got that, 3 out of 3. Otherwise, 3 marks, I'd probably go something like this. 1 mark if actually, I'd probably go something like this, Mr. Dueck. Half mark for that, half mark for dividing by the mass, half mark for sticking in mu mg, half mark for the numbers, and a half mark for the answer. Is that 1, 2, 3, 4? Nope, it's going to have to be 1 whole mark for the answer to make the math work. You know what? I'll give you 1 mark for the original equation, because that's the tricky part. What force is required to move a box at a steady speed? Okay, now I'm going to have to do a full free body diagram. We're going to have gravity, normal force. I guess they want me to find F applied. This is what I'm trying to find. How long am I going to draw friction? Bigger, smaller, or the same size as F applied? Why same size? So I would also have no problem giving you an acceleration, and you'd have to go winner minus loser and get the F applied by itself. But here I can go like this. So I do have a shortcut. I can say F applied is equal to friction. Otherwise, I'd have to do the full winner minus loser equals MA and get the F applied by itself. Friction is what times what? Well, friction is mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. F applied is going to be mu mg in this case. So my final answer, F applied, is going to be, what's mu? I don't know what's mu with you. 0.32 times 20 times 9.8 And I get 62.7. If you added the 2, that's fine. I usually just go to 3 sig figs. Newtons. If you got that right, 3 out of 3. Otherwise, I would probably go 1 mark for that. I would probably go half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. Can you give yourself a score, please, out of 15? If you need to lawyer with me, now is the time.